This is a big moment for me. I live in Colorado, which is not necessarily a free state, so I don't know how any of this stuff works, but we're going to get to the bottom of it. Thank you, gentlemen, for joining me here today. Um, Rafa, just quick. I mean, I bet you were oozing at all that data from the new doctor. That was so cool, wasn't it?
Yeah, I need to talk to her after this. She
Yeah,
maybe
I
have
was
a job
thinking
for
of
her.
you. I was thinking of you. Lots of metrics, which is really cool to see. All right. Well, to set the stage here, I want to talk about obviously Texas fast lane for energy infrastructure and deployment, HPC AI, as well as Bitcoin mining. But why don't we first hear from the three of you gentlemen, starting with Austin, working our way down, who you are, what you do, who you're working for, and how that plays into what we're going to talk about today.
Yeah, sounds good. Thanks, Tyler. Austin Storms. I'm the co-head of the data center business at Galaxy Digital. We're a publicly traded company, sits at the intersection of all things like Bitcoin, uh, crypto stuff that I've never touched. Um, exactly. And we had a big giant Bitcoin mining facility in West Texas called Helios that we acquired from Argo at the end of 2022. Um, at the beginning of last year, we tore it down and we signed an 800 megawatt nameplate lease with CoreWeave, one of the publicly traded neo clouds, and I'm currently in the process of turning over GPU data halls to them. That's what I do. I do all things engineering, design, construction, operations, tech. It's a very fancy mousetrap that we design and build, and we operate over a long term period. So nice to see you all.
I'm Rapha Zagury. We mine Bitcoin, not crypto. I think we are probably one of the last standing large-scale miners that are 100% focused on Bitcoin. Electron is a probably the largest private Bitcoin miner in the world today, although we don't know that for sure. Um, and I'm also a board member at 21.
Nick Gates. I'm the managing director for integrated projects at Priority Power, which is a fancy way of saying basically everything data center. We'll do everything from developing the site, building the substation, managing the power procurement, and especially with the Bitcoin miners, we're a level 4 qualified scheduling entity in ERCOT. We'll also help with all the demand response programs. We're the ERCOT interface between the load and ERCOT.
Okay. So who's not from Texas? Quite a few hands. Okay. Well, let's figure out how this works. Nick, starting with you. From I want to take 10 megawatts, 100 megawatts, a gigawatt, whatever it may be, to mine Bitcoin or to set up an AI data center, to the systems are online, the GPUs are running, the miners are running. What does that look like? What's that process?
So you need to own the land that you're requesting power for. So basically, you go get some sort of land control, in your name. Then you go to the utility. You request that they serve you. The utility runs their studies. If it's a 10 megawatt, you're coming off of one of their substations. So basically, they tell you whether they can serve you right away, what upgrades are needed, and the time frame in order to serve you. So from that point, you basically get a utility agreement, you sign it, you fund it. They buy their equipment, they install their equipment, you install yours. Once your meter goes live, you go and you get a power contract through the competitive market in ERCOT, and then your GPUs are online. Plug them in. It's that easy, right, Austin?
Kind of, yeah.
We'll expand on that. That didn't sound very confident.
I was just saying just plug it in. Every Bitcoin miner knows there's a lot more to it than that, and especially once you get into the GPUs and especially the giant clusters, it becomes a lot more complicated.
Yeah, it gets super complicated. And full disclosure, like Nick and Priority Power are our L4 QSC or qualified scheduling entity at our campus. A long time ago, one of Hoffa's subsidiaries was one of my clients. I was also running like proprietary Bitcoin mining operations within the facility. And I think at peak we were running right at like 235 megawatts at the POI. And so it was massive campus.
And I think your hot tub is heated by his technology. Is that correct?
Yeah, a mere 100 terahash.
Something like that. But no, like when what Nick talks about is like a very what I'll call like simplified or disaggregated view into Bitcoin mining at a smaller scale. Once you start to scale like massive campuses, everything from like your design and architecture of your network fabric really comes into play as you're plugging in hundreds of thousands of ASICs. When I think about Texas and like the path to power, it is some form of land control. I think ERCOT's making that a little bit more complicated, with some of the draft language in Pigger 145 that just passed out of TAC. But typically it's like a ground lease or a surface ownership, and hopefully you own the mineral rights as well. And then you have to like actually do your steady state and dynamic voltage stability studies and get approved by your lead TSP and ERCOT for the load that you're requesting to interconnect into the system. That's really the longest pole in the tent traditionally, before you start putting capital at risk in the form of long lead electrical infrastructure like your main power transformers and GCBs and substation EPC contracts. And so I think of it as like there's a very simple disaggregated view as to what it takes to interconnect into the Texas system. However, like it gets much more complicated as you scale, such as everything in life, right?
I find out you're a methodical guy and you have a lot of hash rate. Thank you for supporting us yesterday, by the way.
My pleasure.
Um,
Bummed we didn't find a block.
we need 7 exahash next time. 7.7. I think that's the amount to guaranteed in 24 hours. Well, guaranteed, but yeah, we'll be up here until we hit one. Regardless, I know you've deployed a lot of sites in many different jurisdictions, many different countries, and you're a methodical guy that thinks through this from the hardware and the software layer as well, all the way down to all the metrics, what I want to get to into in a little bit. But have you seen this fast lane play out firsthand in Texas yourself compared to some of your other sites? Do you want to speak on that a little bit?
Yeah, I'll talk about the results and then how we got there. So we have 70% of our hash rate in Texas. And when we started the election and we started looking, like we have access to sites pretty much around the world, right? And this is still, as Rod said, this is still the best place in the world to get access to energy quick. As a CEO, my number one job is capital allocation and allocation in general, right? So when I get capital, my pocket starts itching because I want to deploy that capital into ASICs, get the ASICs online, and get them to Bitcoin, right? Because if I don't do that, in the meantime, the machines are deteriorating, right? Bitcoin price is going up, network hash rate, as Margot just put it here, is going up, right, exponentially. So my cost of carry is massive every day, right? So getting to market, getting from securing the capital, getting the capital in the bank, and then getting the machines energized is the most critical aspect of what we do. And when we went around the world trying to find place, and we still do that, right? We always end up in Texas to the point that now we're actually stepping back and saying, okay, in the geographical diversification, it's important because, of other risks, of other things. And, we are trying to go to other places, but Texas is still the place where you can get to market the quickest, probably in the world.
Is it the speed to market or the design of the market? What's most attractive here? The overall business friendliness? The list goes on and on of why Texas is better, but just kind of curious what kind of like your priority list is.
It's a little bit of everything, and then price as well, right? You still get very good price for what you get. Like we're doing a project in Brazil, for example, which prices are comparable to what we have in Texas, but you don't have it's not as friendly. The market is not as ready as it is here, right? So it takes time to establish that and get there. And also, I think Texas has been very, friendly in the way to get everybody to market, and really the way that move legislation and all of that could be better. Yeah, absolutely. And I think, they need to adapt a lot to flexible load, and they need to price flexible load much better than they are right now. I think that will come because it's inevitable with where the market is going. This is one of the key reasons of why we remain at Bitcoin, because in Bitcoin mining, because it's still the most, as Margaret said, the most flexible load that you can ever have. And I think the market is going to wake up to that. And Texas is probably going to be the first one to say, okay, we actually need to have a different kind of way to price this, to incentivize this, because it's different than everything else, right?
Yeah.
I was going to double tap on the fast lane, and I believe that's the title. It's a relative fast lane.
I hear there's some congestion.
There's a long line. So what used to take a year is now taking multiple years. They're addressing that, and they're addressing it faster than other markets are. But at the end of the day, everything has become like highly over requested. There's over 250 gigawatts worth of request in the queue right now. The highest peak we've ever hit is 86 gigawatts. So damn near 3 times the load that we've hit at our peak is what's being requested in new additional load. So, it's not easy. Just go request it and you get it real quick. They're working through that. They're working through it. I don't envy them in their position. Everyone wishes it was going faster, but they're working through it the best they can.
Well, the fact that there's a line shows that this is the market's decision for the best place to deploy, right?
The line's kind of everywhere.
The line's kind of
Ever
everywhere.
since AI stopped caring as much about power price, it used to be the deregulated areas of ERCOT only. There are regulated areas of ERCOT. Now it's every utility is being hit. Every utility across pretty much the entire country is being hit, and like they're getting multiple calls a day. Several utilities are hiring new positions just to like field those inbounds and filter them out.
Would you still say there are some aspects of Texas that have no friction points that make it the fast lane? And what would those be? And are they different for AI versus mining? I'm actually curious about that.
Currently, they don't have a way to study the two differently, so there is no real differentiation there. In terms of, like, they give you the same utility agreement. You have firm power if you want it, one way or the other. At the end of the day, like, they look at your request the same. They don't have a way to model the flexibility right now. So we are still the relative fast lane. So compared to other areas, we are much faster. And on top of it, we're a better market because we have we're sitting on natural gas. We're business friendly. We have now the most solar, the most battery, the most wind. We're naturally resource rich here, and our interconnect process on generation and load is quicker than other areas. So we will see some energy price spikes, but that is the market signal to go build new generation, which is good. It can happen here, 2 to 3 times faster than it can happen in any of the other ISOs. So that flywheel goes faster. We'll develop more here than anywhere else. And it's partially because of the resource, partially because of the business environment.
Austin, my understanding is you guys kind of stumbled upon pre-approved ERCOT grid capacity with your site. Is that the case? Or was there a lot of challenges you still had to face when you got that site here in Texas?
I will say what was pre-approved was the original 200 megawatts that Argo interconnected. We then had to expand the interconnection capacity over the first 6 months after acquiring it at the end of 2022.
Okay.
And so what was pre-approved was very limited. And then we took the steps with Nick's help and Priority Power's help and our friends over at ERCOT, our frenemies at ERCOT. And expanded that up to the 800 megawatt, what is the firm interconnection capacity at that campus today. Fast lane, like Nick said, there really is no fast lane at this point. They can't differentiate between a Bitcoin mining flexible load and a AI HPC firm 24/7 load that swings between 30% of its TDP to 150% of its TDP within the data halls. And so when you think about Texas, at least from I'm putting my AI HPC hat on, right? Like the fast lane compared to other ISOs and RTOs is directly impacts the net present value of the tokens that you're generating and the revenues that you're generating from those tokens. And it's the same thing for Bitcoin mining, where if I have a 6-month delay in my interconnection process, or if there's any type of uncertainty in another ISO or RTO where I'm trying to interconnect, it's just degrading the NPV of the hash rate that I'm expecting to produce, while the machines are likely deteriorating in price as well, because everybody's on the hamster wheel that is Bitmain and WhatsMiner and everybody else. And so we like Texas. We think Texas is the best place to build for all the reasons that Nick said. Energy dominant everywhere else is what I'll say is energy subservient to Texas. And we think that that's a very long-term successful formula, as whether token prices continue to decrease or network difficulty continues to become a challenge for Bitcoin miners and their margins, it's beneficial for both.
So no real shortcut to expand an existing site. You still got to do the load assessment. You still got to loop in you guys, Nick, to make sure you get it done right. And there's the queue. You run into that.
There's a queue. There's no shortcut, but our process works faster than others.
Understood. Huff, I want to ask you, so at the scale you guys have hash rate with 70% here in Texas, congratulations. Help me understand this as a novice coming into the larger mining at play. Power purchase agreements, Is it spot retail? Do you have your own generation? Is there any behind the meter? Because I imagine that you mentioned capital markets. For a novice like me, like I said, I imagine that's part of the collateral, right? Is like the actual power agreements in the generation. Do you want to talk on that a little bit? How does that work?
Yeah, unfortunately, in Texas, we have one site that we own only. The others, we host, and on the site that we own, of course, we negotiate all of that. Um, just mention something else, which I was going to mention before. Like there are other markets that are starting to move, and particularly I think in flexible load side, like we've had a lot of success in Brazil recently, and there we are starting to see people understand the fact that you can price this very differently. You're at the marginal cost of power, it's zero, right? When they are curtailing at the power generation side. So I mentioned this, I think, in the last meeting that we had here. Like when we started exploring Brazil, we go to these meetings with the energy companies. They're like, "Oh, there's a lot of curtailment in Brazil, a lot of curtailment in Brazil." And I kept telling, like, "No, no, no, I don't want curtailment. We already have a lot of curtailment in Texas. I want a place that there's less curtailment." And then they turn to me like, "No, you're not understanding. The curtailment here is in the power generation side. We turn off the turbines, we turn off the power generation because we can't put it in the grid. The grid is stressed, and we would actually pay a penalty if we put the power to the grid." And when I told them, like, "Well, we can just put miners right there, and at the time, instead of you putting it to the grid, you put it to the miners, right?" They immediately click like, "Oh, that actually we love that because that's power that is being, just going to waste, right?" And we're starting to develop a market. They're starting to think about developing a market there around, the marginal cost of energy, and then having PPAs are going to be very different than what we've seen in the past, right? I think eventually that's going to come to all the markets, right? We have this beautiful thing with Bitcoin mining, which is, I don't have clients, different than AI HPC. My client is a protocol, right? So as Margo also said, if I shut down the machines, no, I'm not going to have a client pissed off. And actually the network is going to be happy because somebody else is probably going to find that block, right? At some point. And so that it creates a very different kind of dynamics and, any other industry out there. And this is one of the key reasons why, we are sticking to Bitcoin mining because there are several factors that we look at it. We think the energy markets are going to transform. They're going to be very different in the future. And I also think the dynamics in the Bitcoin market are going to get better, right? And as you were saying, like, up until a while back, Bitmain would set all the prices, would set all the terms. It's changing also because not a lot of people are buying machines at scale, right? So in terms of network hash rate dynamics, I think the one thing I saw of Margot's presentation, I think it's wrong. I think her model is broken on network hash rate because it's not going to continue to grow in the same way that it was growing because a lot of people are going out to AI HPC. A lot of people are just migrating. We've got to the next halving. If we stay where we are, the number of machines that are actually, lower efficiency, they're actually going to have to be turned off. If we stay at the same hash price, it's massive, right? And the dynamics, I think now when you look at the intersection of what we're seeing in terms of energy markets changes and potentially what could happen, and also the timing for Bitcoin, I think it's the best time ever to be in Bitcoin mining.
So you guys are staying true to Bitcoin mining. I just kind of want to ask one question on that. If you had a massive site in ERCOT, multi-hundred megawatt that could be used for AI, HPC, and theoretically had a higher return to your shareholders by switching it, what justification do you give to keep it Bitcoin mining?
I wouldn't. I would sell that site at a multiple, get the money, and buy Bitcoin.
Mic drop.
Good answer.
You mentioned something, Huff, that I want to double click on. So the hosting sites, I imagine, that really allowed you guys to test a lot of different things very quickly, hardware and software. Has that helped you come to a standardization, a better understanding of when we are going to get our own site and deploy fast in the fast lane, ideally, you know exactly what you want and how you're going to set it up? And then Austin, I think you should jump in on this too, because I imagine you guys have both learned this over time with more and more hash rate coming online.
Yeah, we made a lot of mistakes in the beginning, but that enabled us. We made mistakes when we were smaller, And it enabled us to create like new standards also in terms of hosting agreements, right? How we have that, how do we align incentives, right? Even in having brokers inside. So if a site is going to be sold, we actually have first look, right? So things like that were things that, made us get much better in what we do with time. And just like in Bitcoin, we try to align incentives as much as we can. So we were very criticized in the beginning, a question about the profit sharing model, which is what we usually do. Right now, as margins compress, it almost works as an airbag, right? Because margins compress and you pay less for the host. So in terms of sustainability, being Bitcoin, you learn, in the hard way that you have to survive the bear markets. So everything that you do in terms of like how you're thinking, you have to think about, even at the bull market, you have to be thinking about what's going to happen at the bear markets, right? So a lot of it was aligned so that, we get to the point now our team is extremely lean. So if you look at the cost curve, right, we have one of the lowest production, if not the lowest cost of production of Bitcoin. So this guy that is producing Bitcoin at 80,000 is going to go away. This one's going to go away. This one is going to go away. And hopefully by the time it gets to us, hash price market goes back to balance, right? It goes back to equilibrium and hash price starts to go up again. And we're still going to be there.
Any thoughts, Austin?
I think at the end of the day, like when I think about Bitcoin mining versus AIHPC and all the long form documentation required to interconnect sites, like Hoffa's probably seen more campuses than I've seen at this point. You guys have a ton of different distributed hash rate, I'll call it. I started my career as like founding engineer at Great American Mining, and we did a bunch of like off grid stuff in North Dakota and Wyoming and Pennsylvania and Oklahoma. That some of it was great, some of it was absolutely disastrous. Right? Pivoted to on grid, understood like reliability matters more than pretty much anything, whether it's Bitcoin mining or AI/HPC, and then like through where I sit at Galaxy, I saw a ton of different facilities that either came to us for financing or came to us for machine financing or came to us for wanting to host ASICs that we owned. And we learned a lot through that process. We learned a lot about what not to do. We learned a lot about what makes a site successful, whether you own it and you proprietarily operate it, or whether you are just putting ASICs there under like a profit sharing agreement, like Hoffa said. There's no better, I think, teacher than time in the market. Like that type of experience is really, really difficult to glean unless you are in the arena and operating on a day-to-day basis. And I think that, over the last 7 or 8 years, like I've learned what makes Bitcoin mining sites successful and what makes them become big headaches for guys like me and Hoffa. Yeah.
I was gonna say, Hoffa said it more directly. A lot of mistakes. Yeah, that's the only way you really learn. And on the AI side right now, the computers are changing rapidly, which we kind of saw on the Bitcoin mining side. How are you designing your facility to kind of like incorporate future-proof it? I ask about your site specifically because it's one of my favorite mistakes of all times. Not you, but your predecessor basically ordered the newest machine, which was not to their knowledge, slightly, I believe, taller, and they had like immersion tanks. So basically, they ordered 200 megawatts of immersion tanks that no longer fit the machine that they ordered. It fit the previous model. So back to my question: future proof. How do you do
I
that?
have war stories about that I will tell at the networking cocktail.
It's almost like we need a standard or something.
Yeah, future proofing is really difficult, right? Like I agree, a standard architecture and form factor would make everybody's life a lot easier. Like you're not going to get it except from maybe like the proto team, right? I think that future proofing for Bitcoin mining is going to remain difficult unless you own the entirety of the stack. Future proofing for AI/HPC, really like the form factor of the cabinets doesn't change much. The cabinet densities are like very rapidly evolving. I think what we saw previously was like 34 kilowatt cabinet densities air cooled to now I'm deploying like 140 kilowatt liquid cooled cabinets within our facility. The next generation is somewhere between 250 kilowatts and 300 kilowatts a cabinet. And so when you think about electrically and mechanically designing for that type of optionality, it's just really difficult. The physics are the physics. At the end of the day, I think like RPPs or busway distribution helps somewhat electrically, but the load is still the load mechanically. And so you when when you design the facilities, like at least from our perspective and what I do at Galaxy, I try to make as much of the infrastructure like modular and pre-built and in the form of like what I call an integrated power assembly or integrated mechanical assembly, such that it's built offsite, it comes in, we install it, recommission it, and then in the future, if there's a step change or a material change in the technology, like I have to pull that out and I replace those modular pieces of infrastructure at the same time the facility is still operating because it's built off site. And so we think about optionality in that way for future proofing. But Bitcoin mining is fairly difficult to do that with.
This is just to add one thing. I think this is one of the most underpriced risks with AI HPC, because at the end of the day, when you're talking about AI HPC, the capital expenditures that you're going to have, they are a few orders of magnitude larger than where Bitcoin mining is. And that means that if you make the margin for error is like this. So everybody looks at the revenue and say, yeah, they signed this massive contract. These are massive revenues, billions and billions of dollars, right? But the capital expenditures that you're going to have to get there are also massive. And you're still in an industry that technologically you're still at the early stages. And if there's anything that the history of technology has shown us is that things are going to move in step changes, right? That's a guaranteed. And a lot of people are going to find out the hard way when, new technology comes in that their margins are ever like this and the mistakes are going to be catastrophic. I think that's, of course, it's not going to happen with everybody, but with a lot of players out there that are not thinking this through, this is a massive risk.
Yeah, that makes sense. Did these kind of in the building pain points, Nick, do they impact the work you guys do at all, or do you just encourage them to think about it? They think about it themselves from learning from pain, or yeah, why'd you ask that question? I'm just curious.
Just pure curiosity.
Okay.
Yeah. At the end of the day, we built the substation, and they take it from there. So not too much.
I understand the majority of the work you guys are having to do. Tell me if this is true. I was trying to research some of it. These load assessments, and then with the hyperscalers kind of saying, well, I want 10 sites, and really they're just hoping 2 of them get through the load assessment, but it ends up causing a lot of rework because each load assessment's depending on the others in the stack. Is that how it works?
I think the hyperscalers pick their spots a little better. Developers, on the other hand, the early stage guys, they'll put in 10, hoping to work out. There have been some changes recently that aren't fully implemented that should clean that up some and have people do a little better on siting. So, essentially, the cost to request load 75 megawatts or larger is going to be $50,000 per megawatt just to request. So no developer's going to go do that, hoping for 10 sites, at 10 different sites. Now they're going to, sort of like the generators do, they're going to study the transmission system a little better to where they think they have a higher degree of success. And, they're going to pick their spots. They're going to size it, appropriately. If they think that area can handle 2 gigs, they might, request a gig there as opposed to previously 3 gigs. Hey, let's see what they come back with, and if they'll do some upgrades. But now the costs are going to change the behavior, and I think a lot of that will drive towards better requests, fewer requests, and easier approval process.
Trick question for you. Like, I think the high tide rises all boats, right? So of course, right now all sites are trading at a premium, and we've seen people come to sites that are definitely not AI HPC ready, coming in and paying multiples for that as well. Are you seeing a segmentation of the market, like high quality and low quality, or not yet? Because that's another thesis that we have, that's going to come at some point.
There definitely is a scale, and it's basically a location, timing, and size, where further out time wise it is, less valuable, further out from population, less valuable. You know, on the size, if you're 50 megawatts, where before you needed to be really close to Dallas, Atlanta, Phoenix, Now you can be a little further, or you can be at a tier 2 area to be considered AI HPC. If you're in that 5 to 20 megawatt range, you still need a very good location. There are some people willing to take like a little further out risk and willing to take the time element on their side to go and get additional upgrades or bolt on generation to it. But AI is going to start in the most valuable spots, and then it's going to spread out similar to what Bitcoin did. The only difference is they care a lot less about power price. And I think basically more of the risk factors you can check off on a site, and as more sites are getting different risk factors, especially around the zoning, currently, like we're going to see people going out further than you would expect, going smaller than you'd expect, taking sites that are further out timeline than you'd expect, just because nothing else is available. So, I mean, right now you're kind of looking at either someone had years into a project already, or they're trying to buy generation, or they're trying to buy a site that's just approved that lines up with about the same time as generation. So it's already getting to the margin on availability.
As we wrap up here, I'd like to hear a piece of advice from each of you for the audience on if someone's goal was to deploy in 18 months, I don't even know if that's possible anymore right now, but navigating all the things discussed, from the risks that you're trying to avoid to the hardware infrastructure and the red tape that you're cutting through, Nick, what advice would you give to someone who wants to set up large scale compute energy infrastructure here in Texas? And then we'll work our way down.
Bring a big checkbook and just buy a site that has already checked off the risk factors. You'll make the multiples on the other side.
First of all, run the numbers. Run as many simulations as you can.
Just write the check.
No, that's the second one. So the second one, make sure that you have the right capital structure, right? So it's not only getting the check, is making sure that the check doesn't come with a lot of string attaches, not a lot of dilution, not a lot of costs, right? That it's actually going to wreck you down the road. Capital structure is and has always been the most important element in mining, and it's going to be in AI HPC as well.
And where can some of this data be found about the Bitcoin mining network and all of the hardware and infrastructure? I think you just released some tools of your own. Is that true?
Yeah, we're open sourcing all of the analytics that we have at Electron. So all the research that we've done, all of the data that we've done, if you go to electronics.dev, it's up there, like literally hundreds of charts. Like all software should be open, and we're leading the charge. So for the small miner to even our competitors can go there. The good thing is that most of our competitors don't run the numbers, so they don't care. So that doesn't matter.
And in terms of the research, I heard through the grapevine they might be trying to hire a doctor to help with their analytics.
Austin, some tips.
I'll echo what Nick said. This is large scale Bitcoin mining, large scale AI HPC compute in Texas has now become a bring your checkbook and do your diligence game. For the first project that we did at the Helios campus, I think we brought like 400 million of equity to that, and then raised another 1.4 billion from Deutsche in a senior secured credit facility. And so like when you think about just the capital expenditure, that's just to build the thing. That's not even for the GPUs that go in the facility, and it doesn't include all of the pre-development work that gets you to a place where you can actually get the facility and the campus underwritten. And so I think the trade that was, you get an option agreement on land, you get an interconnection agreement that's signed, like that was a great trade for years. Now the market is very, very much changing, where the true users of compute, the hyperscalers and the neo clouds, they care about reliability. They do not really care about power price. And so if I was deploying in Texas and I was doing Bitcoin mining, like, I don't hate to say it because it was my first love, like I would focus on behind the meter solutions and flare gas solutions.
Go find a decommissioning wind farm.
Yeah, decom wind farm, sure. I think like there's going to be some costs associated with repowering those assets as well. But one of the first sites that we did in Texas was actually a very small 16 megawatt facility that was purpose built for immersion. I bought that site through Nick at the Priority Power team under an Encore OneSpan, which was like very preferential on my utility rates from a like TCR perspective. And so like small sites still exist, but Tyler, to your question, like if you want to build large scale compute in Texas, tons of diligence, like Rapha said, tons of money up front, like Nick said, and then like you better have a team that can execute on the build, because there's not a lot of folks that can do this. It's more difficult than a lot of people imagine.
Well, whether you think that the energy connection's the value, the Bitcoin's the value, or any of the like, AI, HPC, the Bitcoin itself, make sure to come talk to these guys. Huge round of applause for Austin, Rapha, and Nick. Thank you very much.